Okay, Unit 8 Test Study Guide, question number 13. Mr. Buckley is buying apples at the commissary. What is the probability that he does not buy 2 apples? Okay, there's a probability that of 1 out of 12 that he buys 0 apples, a probability of 1 out of 6 that he buys 1 apple, a probability of 1 out of 4 that he buys 2 apples. Again, that's 1 favorable out of 4 possible. 3 is 5/12. Buying 4 apples, 1/12. Not buying 2 apples would mean all of the rest of these would be good outcomes or favorable outcomes, what we're looking for. So what you could do, the probability of not 2 then would be 1/12 plus 1/6 plus 5/12 plus 1/12. You could do it that way. You could add those all together. You'd need to get a common denominator for this, add them all together, and then probably reduce your answer. But the shortcut is this. If these are all the possible events, buying 0 through 4, if these are all the possible outcomes, the probabilities of all the possible outcomes add up to 1. So the probability of not 2 would be 1 minus what we're not going to have, the 1/4. Him buying 2. This is the only bad answer. Subtract that from 1, which, yeah, you would still need to get a common denominator. That's 4/4 minus 1/4. That is 3/4, and that is our answer. Okay? I would also point out to you, if they'd ask for the probability of buying more than 2 apples, you would add together these 2 probabilities. Okay, these 2 possible outcomes, the probability of these 2 possible outcomes. And that would be the probability of buying more than 2 apples, these 2 favorable outcomes. Okay, on to question 14. Mr. Jordan wants to buy a new TV. What's the probability that, again, he does not buy a Sony? Same as question number 13. These are the probabilities, only they're written in decimal form. Again, the shortcut is they add up to 1. If these are all the possible outcomes, their probabilities add up to 1. So I'll go straight to the shortcut. The probability of not Sony is going to be 1 minus 0.75. 1 minus 0.75. Put a decimal point, fill in with a couple of zeros. You have to borrow. This would become a 10, but then you borrow, it becomes a 9. That would become a 10. 5, 2, decimal point stays right in a line. 0.25 is our answer. The other way to do it is add up all the other probabilities. Since all of the other ones would be favorable outcomes, add those together, and it would be 0.11 plus 0.13 and 1/100. Add those together, and you will get the exact same answer we just got. Okay, question 15. Before we start these, understand what these words mean. A simple event. That is a single event, such as flipping a coin, rolling a dice, pulling a deck pulling a card out of a deck of cards. Those are simple events. Spinning a spinner. That is a simple event. Compound just means you're going to do more than one simple event. So spinning two spinners, spinning a spinner and flipping a coin, that's compound. Dependent? Dependent is when the first event affects the probability of the second event. Okay? They're dependent. That second one is dependent on the first one. Okay? It changes the probability of the second event. Independent, the two events don't have any effect on each other. That's what these words mean. And that's the key to answering these questions. A number cube is rolled once. That's a simple event. You're doing one event. And because it's a simple event, it doesn't have any effect on anything else, so it is independent. A coin is tossed twice. You're doing it twice. That's more than one simple event. Flipping a coin would be a simple event. This is compound. Dependent or independent, the flip doesn't affect anything about the probability of getting a heads or tails on the second event, on the second flip, so these are independent. Okay, 3 cards are pulled from a deck with replacement. Okay, first off, it's 3 cards. This is compound. You're pulling a card from a deck and then you're pulling another card. This is more than one event. This is compound. With replacement means that you're going to take the card out, see what it is, and then put it back into the deck. So the deck is back to where it started. Pulling out that first card does not affect the probability. You're back to a deck of 52 cards. So with replacement is independent. Independent events. The difference, number 18, 3 cards are pulled from a deck without replacement. Again, the keys, it's 3 cards, so this is a compound event. Without replacement, if you take out the card and don't put it back in the deck, the deck has been changed. The probability has been changed. Instead of having 52 possible cards to choose from, there are now only 51. This is a dependent situation. The probability of the first affects the probability of the second event, and the second would affect the probability of the third card because the number of cards in the deck keeps changing. Okay, so that's independent and dependent.